In this video, we'll discuss the problem and conceptual exercises of chapter 4 from the book James's Walker. So let's start. Now, in this question, we are given that you decide to combine diving from the board and shooting a basketball through a hoop. It's a very interesting question, and there are three parts that we need to solve. First, we're going to solve the A part. Now, in the A part, what the question says that you throw the basketball horizontally from a position of 4.50 meter above the ground. If the average landing spot is 6.25 meter horizontally from the initial position, what is your average launch speed? So V0, the initial speed with which you launch the projectile, is what we have to calculate in the A part. So first we'll focus our attention on the A part. Okay, now when we exploring the projectile motion, we studied that we can see the motion of ball in the horizontal and vertical direction separately. So what I'm going to do is we're going to see the motion of the ball in the vertical direction first, and for that the basic equation that we can use is y is equals to y0 plus v0 y times t plus 1 over 2 a y t square. So by using this equation, we can find the position of the ball at any given time, or vice versa, we can find the time of the ball at a given position. So initially we know that the ball was at a height of 4.50 meter above the ground. So let this be h, this height be h. So y0 is the initial position, so it will be h, and the final position becomes 0. So this will be equated to 0. And initially the ball was thrown horizontally, so there will be no component of velocity in the vertical direction, so this is also 0. And acceleration on the ball is the acceleration due to gravity, so ay we have minus g. So from here we can find one equation. This is 0 equals to y0, we have h minus 1 over 2 gt square, and from here this t would be under root 2h over g. And if you see the motion of the ball in the horizontal direction, so you can use this equation, x equals to v0 times t. This is speed multiplied by t will be equals to x. Now what this x is, the horizontal distance traveled by the ball in given time t. So it says that the ball travels 6.25 meter horizontally from the initial position. So x we have 6.25. V0 is the initial speed in the horizontal direction. This is basically V0 x, and t we have calculated this, so we can put it here. So this equation becomes x is equals to V0 x times t is under root 2h over g. Now from here we can find this horizontal velocity or the speed. So this is a V0 x, this would be equals to x under root g over 2h. Now put the values to find the answer. So v0 x, this would be equals to x, we have the horizontal distance traveled by the ball is 6.25 meter. So this is 6.25 meter multiplied with under root g is 9.81 meter per second squared, divide by 2 times h, and the h value is 4.50. So solve by using a calculator, and we'll get the answer to be 6.525 meter per second, or you can write after rounding off 6.53 meter per second. So this is the answer for the A part. Now let's discuss the B part. Now next we're going to solve the B part, which is more interesting. It says that now you step off the diving board and launch the ball in order to make a basket in a hoop that is 3.75 meter horizontally from the ball. So you jump off the ball, and at this position you launch the projectile, and at this position the horizontal distance between the ball and this basket hoop is 3.75 meter, and this vertical distance from the ground is 1 meter, that you can see, right? Now we need to tell that at what time after stepping off the board you should launch your ball. So we have to calculate the time after which you launch the projectile after stepping off. So initially this was your position, and then you reach here, and then you launch the ball and finally the ball comes at this position, and this is just 1.5 meter above the ground. Now what I'm going to do is I'll first find the time taken by the ball from this position to reach this position, and for that we can consider the horizontal motion of the ball. So use this equation, x is equals to v naught times t, and the horizontal distance traveled by the ball from this position to this position is 3.75 meter. So this is 3.75 meter. V naught is the speed of the ball in the horizontal direction, which will be same that we calculated in the A part. So this is basically 6.525 multiplied with time t. Now let this time be t1. So from here this time t1 is equals to 0.5747 seconds. So this is the time taken by the ball to reach from this position to this position, or you can say that in the vertical direction you travel this much of distance in this much of time. So let this is t1. Now next what we can do is we can find the time taken by you and the ball to travel this much of distance vertically, right? So let this time be t2, and for that we can use the simple equation, which is y is equals to y naught plus v naught y times t plus 1 over 2 a t square. This is basically ay. Now initial position, this was 4.50 meter above the ground, so y naught we have 4.50 meter, and this is the final position, which is 1 meter above the ground, so this is 1. V naught y, there was no initial velocity in the vertical direction, so this is 0, and ay we have minus g. So put all the values here, and this time becomes t2 here. So this is 1 is equals to 4.50 plus 1 over 2. Ay is minus g, so minus 9.81 meter per second squared multiplied with t2 square. So from here we can easily find the value of t2. So t2 would be equals to this is 2 times 3.50 divided by 9.81 and its root. So this would be equals to 0.8447 seconds. Now this is the total time taken by you from this position to this position t2, and this time we have calculated to be this is t1, we have 0.5747, right? So what would be time taken by you to travel this much of distance in the vertical direction? So let this be tc that we have to calculate. So tc would be equals to t2 minus t1, the total time minus this time t1. So this is the answer for the C part, that is t2 minus t1, and t2 we have 0.8447 and t1 we have 0.5747, which comes out to be as 0.270 seconds. So this is the answer for the B part. Now next in the C part we need to find that what is the horizontal and vertical component of the ball velocity at the instant of launch. So at this instant, what is the component of velocity in the horizontal direction? This is Vx, and what is the component of velocity in the vertical direction? So this is Vy. Now throughout the projectile motion we studied that the horizontal velocity remains the same. So this Vx will remains the same. This will be equals to V naught x. If we are able to calculate Vy, we can give the answer. So for the Vy, what we can do is we can consider the motion of the ball in the vertical direction. So Vy we have V naught y plus Ayt. So at any time t we can find the speed in the vertical direction. So at what time we have to find? At this time, and here time is 0.270 seconds. This is tc basically. Here the time is tc. So you can put it at tc here. Now you can put the values. V naught y, this is 0. So Vy is equals to Ay. Now Ay we have minus 9.81 meter per second squared multiplied with tc 0.270 seconds, and that is equals to minus 2.65 meter per second. And negative sign basically denotes that the component of velocity will be in the downward direction, right? Now we can easily write the vector form of velocity. So this is velocity at the time of launching. So x component we have 6.53 meter per second and the unit vector is x cap. Then plus the y component, we have minus 2.65 meter per second, and this is y cap. So this is the answer for the C part. Now this question was a very tricky question, but the thing that helped us was the fact that the horizontal component of the ball's velocity remains unchanged throughout the flight. So this fact was very important, that make this question a little bit easier. So I hope you got this problem. If you have any doubt, you can comment me in the comment box below. Now this question is based on aircraft collision, and in aircraft collision there is an important rule, and the rule is, if the heading from your airplane to second airplane remains constant, the two airplanes are on a collision curve. Now this rule is not only valid for the aircraft, it is valid for anything that you are driving, like a car, snowmobile, anything. Now let's get back to the question. Now the question says that we have two airplanes. Airplane 1 is at a position x, 0 at time t equals to 0. And the aircraft 2 is at the position 0, y at time t equals to 0. And the airplane 1 is moving along the positive y-axis, and the aircraft, this airplane 2, is moving along the positive x-axis. Now we are given that the speed of the airplane 1 is v1. Now in the A part, we need to find that what speed must airplane 2 have if the airplane are to collide at point x, y. So if they collide at this point, what would be the speed of the airplane 2? So the time taken by both the aircraft from their initial position to final position will be same if they need to collide. So t1 should be equals to t2. And what is time? Time is distance over speed. So t1 would be, so for aircraft 1, the distance traveled is y, and speed we have v1. For aircraft 2, we have a distance to be x, and speed is v2. So from here, the expression for v2 will be equals to v1 multiplied with x over y. So this is the answer for the A part. Now next it says that calculate the displacement from airplane 1 to airplane 2, that is this value we have to find, and we can use the results that we have calculated in the part A. Now displacement vector, so displacement vector delta r is r2 minus r1. This is what we studied earlier also in our previous chapters. Okay, now the position vector r2. So this is a position vector r2, so it will have some x component and the y component. So what will be the x component? It will vary according to the time. So speed, we have v2 here, this thing. So v2 times t, x cap, this would be the x component, and the y component remains the same, that is y. So y cap. Now then minus r1, this is the vector r1. Now here the x component remains the same throughout the time, so this would be x cap, plus the y component will change according to the time, so speed multiplied with time, and this is y cap. Now add x component to the x component and y component to the y component. So delta r, this will be, so this is v2 times t, this is x cap, and this is also x cap, so minus x cap, then we have plus y minus v1t times, this is y cap. So this will be our displacement vector delta r. Now next in the C part, we have to use the results that we explored in the B part to show that this is equals to this. Okay, so basically we have to take the ratio of the y component over the x component. Okay, so this is our C part. So delta r y component divided by delta r x component. So y component, we have this thing, so y minus v1 times t divided by, this is v2 times t minus x. Now do one thing, take y common in the numerator, this would become 1 minus v1 over y times t divided by, now v2 we have calculated earlier to be this value, So this is v1 x over y minus x. Now I missed out t here. This should also be multiplied with t. This is v2t. Now do one thing, take minus x common from the denominator. The numerator remains as it is, so y times 1 minus v1 over y multiplied with t divide by, so minus x is common, so this would be v over y multiplied with t and with a negative sign plus 1, because we have taken minus x common. So further we see that the numerator and the denominator, this thing is same, this will cancel it out and we'll get y over minus x, and this was the result that we need to prove, that was given in the equation. Thus we can write that delta r y over delta r x is equals to minus y over x. So this is the required answer for the C part.